In graphite, each carbon is combined with the 3 carbons so that each carbon is having one free electron. And you can see it will form hexagonal arrays. Hexagonal array means one layer. So like this, each carbon is bonded with the 3 carbons in graphite in the same plane and giving the hexagonal arrays. And one of these bond, if you notice it, it will be a double bond, and that is why the valency of carbon is satisfied. All of you understand? One of the bond will be double bond. That is the reason the valency is satisfied, but still one electron will be there in each carbon. That is the reason you can notice it. A graphite is a good conductor of electricity. Is it okay, everybody? Please. All of you understanding or not? So, if you take the graphite, the hexagonal arrays being placed in layer by layer, layer by layer, layer by layer, one above the other. That is how the graphite is forming. So this is the first layer. If you consider one of the hexagonal array, above it, it has been kept another layer like this. If you are getting, for example, our pencil is made up of graphite only. So in the millions of layers has been arranged one above one. That is what it is forming the lead, pencil lead, or we can say the graphite rod. So each carbon is combined with the 3, and you can see graphite, the bonds between the layers, different layers, weak forces are hold the layers of carbon atom. That is the reason. Is it possible to sharp the graphite easily or not, everybody? Yes or no? All of you? Is it possible to sharp it or not? Easily, because between the layers, the bonds are present, which are present, they are weak bonds. So that is why you can notice it here. They have been represented with the dotted lines. So dotted lines indicating weak forces. So that is the reason we can easily cut the graphite layer by layer. But if you notice it, in between the carbon and the carbon, the strong bonds are existed between one carbon and another carbon. But that bond is what bond, guys? Covalent bond. But even though covalent bonds are weak in nature, but the covalent bonds formed by the carbon is very strong. Even yesterday I told you the reason. What is the reason behind? A reason behind is what? Because of a size of the atom size is very small, so that the electrons are tightly held by the whom, guys? Nucleus. So that is what it is, the graphite. Now, these graphite, even we can prepare artificially from the coal. So how to prepare a graphite from the coal? So let us see. So if you want to prepare the graphite, basically we have to choose anthracite coal. So this is the one of the hardest coal and toughest coal, which contains highest percentage of carbon, around 98% of carbon. How much percentage will be there? 98% of carbon. So this anthracite coal, if you have been heated with the silicon dioxide, so that is what we will say silica, okay, silica, under the, that is why if you heat under the temperature 2273 Kelvin, and we are using even carbon monoxide also as a catalyst, then we are going to get silicon carbide, and again if you are heating around a temperature of 2273 Kelvins, then we are getting carbon plus silicon separately. So now here what the carbon which we are obtaining, that is what we used to call as, what we used to call, guys? We used to call as graphite. The before carbon which we have taken is it is also a carbon, but it is the anthracite carbon. Okay. Now the carbon which we are obtaining is the graphite carbon. So this is how we will obtain the graphite production from anthracite coal. If you want, we can learn. Otherwise, it's not even necessary. So, a graphite is hexagonal rings or hexagonal arrays. What is the structure of diamond? Structure of diamond is what? Tetra and
Octagonal.
tetra plus tetra will form octagonal structure. And here, each carbon combines with only 3 and it will form hexagonal rings or hexagonal arrays. So each array has been layered on above and above. Between the layers, weak forces are present so that we can easily cut them, we can easily sharp them. But between the carbon, they'll be having how much? A very strong force of attraction. That is what coal and bonds are existed. But you remember, each carbon is having one free electron. That is why it will be behaves like a good conductor of electricity. But if you notice, it has been one double bond is present to satisfy the valency of a carbon. You understand, everybody? Yes, please. So that is what you have to remember. So if we take the physical properties, as I said, both are made up of what? Now compare diamond and as well as graphite. Now you tell me, what is both are made up of what, guys? Both are made up of
Carbon.
yes or no? Now, as I told, what do you mean by allotropes definition? Same chemical properties, but what is differs? What differs it is here?
Physical property.
Physical property.
Physical properties. Now, if you compare diamond and graphite, they're having entirely different physical properties. Even though they're made up of the same metal element called as carbon. So means their chemical properties are same, but the physical properties are different. For example, if you take diamond, diamond is the hardest substance known to us, more than a metal. Even we will use diamond to cut the metals also. So if you take this diamond, it is having extremely hard and even it is a very, very bad conductor of electricity, but good conductor of what? Good conductor of
Heat.
heat. Physical properties is differs. Now, coming to the graphite. Graphite is very, very smooth because in between the layers, weak force of attraction, strong force of attraction. Everybody.
Weak force.
Of attraction, and you can see the density of diamond is more because of closeness of carbon atoms packing. But here it is graphite. Between the layers, the internal force of attraction is less, so that is why it is very, very smooth. And as well as if you notice it, graphite, it will be slippery in nature. What is the graphite? Smooth and slippery. But diamond is what? Shiny and hardest. Now, if we take graphite, graphite is a good conductor of electricity like metals. Even though the one and only non-metal which is a good conductor, a best conductor of electricity is the allotropy of carbon. What is the allotropy of carbon? Everybody? Yes. Graphite. So that is what, like unlike other non-metals, that is graphite will behaves like a metal during the conducting of electricity, because each carbon combines with what? Each carbon combines with the 3 carbon. So there are free electrons in each carbon, one free electron. So it will be good act as a good conductor of electricity. So which we already studied in the previous class. Now, if you notice it, coming to the diamonds, as I told you, the production of graphite. So if you want to produce the graphite, you can produce from where, guys? By using a toughest coal, which we used to call as, what is coal called as?
Anthracite.
Anthracite.
anthracite and as well as silicon dioxide. That is what silica used to say. If you have been heated 2273 Kelvin, so finally we will get again a carbon and as well as a silicon separately. So that carbon is graphite. Now, if you take diamond, diamonds also basically they will be made up of by nature, but natural diamonds are the costliest diamonds. Now, these diamonds we can manufacture like that is what synthesized by subjecting pure carbon to very high pressure and temperature. If you have been heated the pure carbon at extremely high temperature and pressure, more than 3000 degrees Celsius, observe, then the pure carbon will turn into a synthetic diamond or artificial diamond. Okay. Now Kevin is asking a question that, so what is the name of the structure of diamond? Basically, structure of diamond is tetrahedral structure. One tetra plus another tetra will combine together and it will form octagonal structure. Is it okay, Kevin? Yes. So that is one. So if you notice it, that is what we can synthesize even artificial diamonds also by burning of pure carbon, extremely high temperature and the pressure. So these synthetic diamonds which are obtaining they are by this burning of carbon at extremely high temperature and pressure, they are small in size and also they are notice it the value of that is entirely different from the natural diamonds. But if you notice it, the only difference between the natural diamonds and synthetic diamonds, size is the only thing. But if you see both, if I'll keep natural diamond and artificial diamond, both are indistinguishable. What do you mean by indistinguishable? Anybody?
Not differ.
Cannot be identified.
Identify which is natural. Yes, that is what. So we can synthesize the artificial diamonds also by burning the pure carbon to extremely high temperature and pressure. So that is what you have to remember. Now, coming to the last, another allotropes of carbon, which has been a recent discoveries like 1970s only they have been like 90s only they have been discovered. So that is what we used to call as, which has been looks like a football like structure known as, what is that called as, guys? Fullerenes. Understanding? So fullerenes are the a third form of allotropes of carbon, which are basically existed in interstellar stars. Means on the earth atmospheric surface the percentage of fullerenes is extremely negligible. They will be present in between the stars only. So that the matter which is existed in the stars, that is what we can see. That is also allotropes of carbon, which we used to call as fullerenes, basically fullerenes. But the most popular fullerene which is known to us is, what is the fullerene which is known to us?
Buckminsterfullerene.
That is what we used to call as Buckminsterfullerene. So remember, a fullerenes means number of carbons are together is only called as fullerenes. So in this fullerenes, basically the carbon number varies from, understanding, varies basically more than, you can take even 3 4 also is to called as a ring only. So that is what, which maybe you can notice it, a gained molecules like the big molecules of carbon will combine together, like more number of carbons will combine together, then we will say it is called as fullerenes. So basically they will obtain a spherical like structure. It will be basically made up of 60 to 350 carbon atoms, 350 carbon atoms, and even above also. So the known fullerenes for us basically varies from 60 to 350. So now they contains even more number of atoms also, but they are unstable in nature. Unstable in nature. but the most stable form of fullerene is Buckminsterfullerene, which contains the number of carbons. How many guys? How many carbons?
60 to 350.
No, that is varies, but the most stable fullerene is called as Buckminsterfullerene, which is made up of 60 carbons. Do you understand, Sai?
Yes, sir.
That is what you have to remember. Okay, everybody. So C60 is named as Buckminsterfullerene, is the most stable form of fullerenes. Please remember that. Common and stable form of fullerenes is C60, named as Buckminsterfullerene. Basically, all are fullerenes only, but C60 is the Buckminsterfullerene, which contains a most common and stable form of carbon. That is what fullerenes. So, this allotropy, fullerenes was named by a scientist named, actually he's an American architect, he's not even a scientist, he's an American architect, his name is Buckminsterfuller, because its structure resembles a framework of dome-shaped halls designed by Mr. Fuller for large international exhibitions. So he's an architect of America. So he has been designed some public halls and all for the international exhibitions. So that structure, that halls is similar to the dome-shaped halls is similar to the Buckminster, this fullerene C60. So that is why it has been named as Buckminsterfullerene. So the Buckminster resembles, it will be similar to the which shape? You can see that shape. What is the shape of that Buckminsterfullerene? Everybody? It is resembling what structure?
Football.
Structure. It is resembling the football structure. Remember, which is made up of 20 hexagonal rings and 12 pentagonal panels. Please remember that. 20 hexagonal rings. Hexa means how many? 6 or 5 guys? Hexa. 2, 3, 4, 5, 6. So 20 hexagonal rings and how many pentagonal? Check it there. Football. 1, 2, 3, 4, 5. Penta means how much? 5. So 12 pentagonal structures is there. So that is what it will be there. And you can see its hardness in between the diamond and graphite. It is not like hardness like diamond, soft or smooth like graphite. The hardness is between diamond and graphite. And you can see this is the future of nanomaterials. So this fullerenes only presently we are using in nanotechnology, which will be having a wide importance in future coming generations. And the scientists are trying to develop new materials from these fullerenes. And this fullerene also it will be resembles like a football structure. Because of that, it is called as buckyball, or we can say bucky or bucky, a buckyball, also known as buckyball. Which one? Only the stable form of fullerene. What is the stable form of fullerene? Most stable form is Buckminsterfuller. Basically, carbon number varies from this, but they are not much stable. So that is why you can see all of you, this we are having a wide importance, wide importance of these fullerenes in nanotechnology. Now even we can produce this Buckminsterfullerene by even in our atmosphere also we can produce by vaporizing graphite using laser. Do you understanding everybody? Vaporizing of graphite with the help of laser, powerful laser, we people can produce a fullerenes. And also by heating graphite rod electrically in the atmosphere of helium. Electrically in the atmosphere of helium, we people can produce the fullerenes. So these fullerenes being found in basically like we can say, uh, even in earth also in very, very less percentage in very, very less places. So if you go to the basically in Germany, that is what meteorite in Germany and ancient rocks in Russia and as well as New Zealand, some places they have been found. That is also very, very less percentage. So that is very less sources. But if you go to the stars, between the stars and all, so universe, the fullerenes is present in extremely high percentage. So that is what is fullerenes. And these fullerenes, sometimes they can work as insulators, sometimes they can work as a superconductors also. So that is why they are called as semiconductors, not like diamond, not like graphite. Their properties is entirely between whom, guys? Between diamond and another one is graphite. So this is how we can produce the fullerenes by vaporizing the graphite with a laser or electrically heating in the atmosphere of helium. We people will obtain the fullerenes. So fullerenes is another form of allotropy. The most stable and first identified fullerene is C60. So that is what which is the shape of football, and it is looks like a dome, geodesic dome designed by the US architect. If you put in Google, you will get it. Geodesic dome designed by the US architect for the public exhibitions. So international public exhibitions. That is why it is looks like that. That is the reason it has been named a US architect name called as Buckminsterfullerene, and the molecule was named fullerenes. Everything is fullerenes. The C60 alone, Buckminsterfullerene. So this is what about what is allotropies and what three allotropies properties, how the properties will varies and all. So you don't have much uses also because they are not mentioning anywhere uses in our book. So we don't need to worry about it. Then this is all about it. So till by tomorrow, everybody should learn till versatile nature of carbon. All of you should read. And tomorrow we are going to start with the organic compounds and later the classification of organic compounds, and directly we will go with a concept called as hydrocarbons. The first type of carbon compounds is hydrocarbons. We have to start by tomorrow's and we have to continue. So from there only the real lesson will start, which will be extremely important for our board exam. So let it be with this. I will wind up the today's class. Then tomorrow we will go with organic compounds, and later we will come to the types of organic compounds and properties. So thank you everybody. So till here in page number 62, till page number 62, you all must need to complete it everything, including allotropes. After that, we will continue from organic compounds in our tomorrow's class. So thank you everybody. We'll meet in tomorrow's class.
Thank you, sir.